Hi again, color friends. I wanted to explain a little bit about the color spaces in Photoshop and the other applications that are a member of the Creative Suite, Illustrator. I'm not going to touch Adobe InDesign or Acrobat. I wanted to start off Photoshop. So color spaces, the color space that interests me most in this image, for instance, or in any image. As you can see, I have the info palette over here that's waiting for my cursor to hover any pixels of the image. Suppose I have this image active, so anywhere I point the picker or the cursor of the mouse, I get a readout in multiple color spaces. Actually, there's only two simultaneous readout that one can get out of the current info palette, and I don't think it will change anytime soon. But you see, there's grayscale, RGB, that's the choice of colors we get, and we get this LEB color readout at the same time, which is useful, which I want to talk about today. So any colors has an LEB expression or corresponding numbers, if I can say. This image, or if I open up this image, for instance, this image has RGB or other color spaces properties or readouts, but in this instance it so happens that the image is encoded in RGB, which means that every pixel in this image has an RGB component. If I zoom in and if I place the picker on one particular pixel, you can see that this pixel value is 210 are red, 154 green, 165 blue. So the red component is higher than the other two components, and you know that intuitively matches the visual appearance of that color of that pixel, which is, you know, redder. If you look on the other side, the RGB, and now if I select the LEB and I bring my cursor back, the corresponding LEB readout for this pixel is 71, 34 and 5. 71, 34 and 5. So it means that this color is rather light, on the light side, because the first of the three numbers, the L number, is 71. Let me just quickly tabulate over to Illustrator and show you that the three value for the three components of LEB that Photoshop displays is lightness, which is denoted by the letter L, and then there is this redness, greenness sort of opposition, and this blueness, yellowness opposition, and this is made by the letter, I'm going to do it here, letter A, and this is made by the letter B. Now it so happens that A and B can vary from positive to negative. So on this side, towards, let's say, greenness, the sign of the letter A would be negative, and if we're talking about yellowness, the sign of the B dimension or component would be positive. On the other side, if we are discussing colors that have very high red content, the sign of the A is going to be plus, and for colors that have very high blue content, the sign of the B will be negative. And in the center where these two meet, we have 0, and A and B will be equal to 0. So when A equals 0 and B equals 0, what do we have? We have gray. we have gray, and the only thing that can change this gray is lightness value. The lightness value goes from 0 over here, so 0, and at the other end the lightness value can go all the way to 100. So the closer it is to 100, the closer it is to white, and the closer the L value towards 0, the closer it is to appearing black. And between black and white we have the grays. So if we go back here to Photoshop, let me just pull this window here, and we have this scale. You see this scale? This scale is an RGB document as well, but every step in this scale goes from black. You notice the number says 00 in RGB in the info palette over here. Sorry, I can't simultaneously circle or press or the info palette and the image, because that's how Photoshop is made. But maybe there are other ways, but I don't know them. And so RGB and LAB in this case are both equals to 0. So 0 L, 0 A, 0 B, 0 red, 0 green, 0, that's black, that's 0. And at the bottom I have not created the 100 value, but if I had created a 100 patch value, the readout would be 100L. Now the readout here is 98, and as you can see, when I progress towards black, the readout changes in L. So over here I'm at an L of 40, over here I'm at an L of 15, and you see that 15 is darker than 40, 40 is darker than 50, and so on. 980 is lighter than 50. That's essentially the L scale. The L scale goes from black to white, or white to black. One point also I wanted to make to draw your attention is that any of these color spaces, gray, which are supported in Photoshop. Let me go back to Photoshop over here. Image mode, you see you have grayscale, and let's not talk about index color, RGB color, CMYK color, and LAB and multi-channel. This layout gives the impression that all these scales are equivalent, but it's not exactly the case. What goes on, the reality is that all these scales are related to C Lab. RGB is related to C Lab, CMYK is related to C Lab, and multi-channel is also related to C Lab. So C Lab is like the daddy, the father of all those subspaces. Any colors can be expressed simultaneously in RGB and C Lab, CMYK and C Lab. So for all our printing guys, C Lab, CMYK over here also has its cousins in C Lab. Families. Grays is only like the lightness scale. RGB has these 3 components, and CMYK also has the equivalent 3 components. So when I go back to Photoshop, and here I'm in an RGB document, anywhere I press or the scale or the cursor rather, I get Rgb readout for each of these patches, each of these colors. If I bring up the channel palette, you will see that the channel palette show that there's a red component, a green component, and a blue component. Now, what about the same image, but directly encoded in C Lab? This is a C Lab encoding of the same image. See at the bottom it says Lab Color. That's the document profile, Lab Color. And if I've activated this window, you can see that the channels are very different. This is the RGB image. We have red, green, and blue channel and a composite. And this is an LAB channel, lightness channel from 0 to 100, an A channel and a B channel. Now, if any of these colors have to have by definition some LAB numbers, there cannot be a color that does not have an LAB corresponding color components or coordinates. It's impossible. So in the case of this aqua green, the L is 71, meaning that it's rather on the light side. The A component is minus 32. Let me bring you back to this chart over here in Illustrator. In this chart, the A component is negative, so it means that the color tends toward green, and this is what we're seeing. We're seeing a green component in this aqua green sort of quote-unquote color. It's minus 32. If it was higher than minus 32, let's say like this green over here, we're at minus 39 this time, then they would say it would mean that the green component is higher. Now the B component in this case is 0. In the case of this aqua green, 0. So it means that there's no yellow component over here. But if we bring the cursor over this yellow patch, you can see that the B component is quite high, 78. The scale of the A and the B is not from 0 to 100. It's from minus 128 to plus 128. If I go back to Illustrator, I could illustrate it this way. This is from 0 to 100. We know that. But over here, this would be from plus 128 to minus 28 at the other extreme of the scale. Now, to have a color that is minus 28 or either on the red or the B is extremely rare actually in nature. It would be one hell of a red color to have this, to reach this. Photoshop has to support these extremes, but in reality, you see this red over here, it's not a bad red. There could be a higher red than this, and actually there is, and you can see that I only have 183 red, where I could have all the way to 255 red. Let's select this color for just the hell of it. Select the color, and let's change its encoding. Let's bring it back to, let's leave it to what it was. It was at 42L. So let's leave at 42L, and let's bring 128. You see, it has to be 120, actually 27. And you see the color here now. Let's leave it at 0. And let's assign this color to this patch. You see now, it doesn't look red. This looks like fuchsia or magenta. So let me go back and add some yellow component, but not all the way like this. I don't think it will work. Actually, it does work. It does appear like a very, very saturated red. So you see, I've created a red that's very, very saturated. 127, 127. Now remember, when we're looking at this color picker, there's these flags that light up. It says, you know, that the select the color is out of gamut. So let me click on this icon and see what happens. You see now what Photoshop has done. It has looked at the RGB color space or the CMYK color space. I'm not sure which one it looks at first, but it's found the best match for the original color. Now let's see, it's not quite 255, so there's room for improvement if I want to go 255. But the point to remember is that we have lost the 128 on the A and the B scale. It's no longer 128, it's 71, 58. So, you know, real colors, they don't have 128 as we can display here. And this, we can talk at length as to what is being displayed over here. So, wow, this is a lengthy video. I don't want to overdo it, and let me pause for now. And if you have any questions, of course, I'll be more than happy to answer them, or leave me a comment or write me an email. And we'll see you next time as I try to follow up on this color space discussion. Thank you for watching.